Hello, and welcome to my talk for KubeCon Cloud Native Con Europe 2020. Thank you so much for joining me for Uncharted Territories, Discovering Vulnerabilities in Public Helm Charts. So, ahoy, welcome. Thank you for coming. And my name is Hayley Denbraver, and you can reach out to me on Twitter. My handle is on the screen now. It's Hayley Den and I would love to hear from you. I am a developer and a developer advocate, and I love creating technical educational content. I am coming from my home in Seattle, and I live there with my husband and my super cute puppy. And as much as I love it here, I wish we could be together in Amsterdam. And last year, I actually had the pleasure of going to a different conference at the same venue we were supposed to be at. So I thought I would bring some of the weird conference venue, weird statue vibe to this virtual event. So it's almost like we're in Amsterdam, right? Now, this talk is part of the beginner track. It is for people who are new to the cloud native ecosystem. And, you know, cloud native is really fairly young. And in a way, we're all new, but every KubeCon, there are tons of people who it's their first KubeCon. And I'm just here to tell you, if you're a beginner, if you're new at this, it's A-okay, and I have the talk for you. I also really classify myself in this category too. I'm fairly new to the ecosystem, but I got a chance to take a look at some interesting vulnerabilities that were in public Helm charts. And so even though I'm new, I'm hopeful that this project will be interesting to you and that we can all go away from the talk having learned something. Now, this talk is going to be in about 5 parts. First, I'm going to cover the CNCF and their general approach to security. Secondly, I'm going to talk about Helm as a project and about the security posture that Helm has. And from there, we're going to move on to Helm Chart security. Now, Helm Chart security is distinct from Helm security because what we're going to do is really look at the charts themselves and the images contained within them. And after spending a bit of time there, I'm going to step back a little bit and really bring it down to an individual level and discuss what everything we've talked about means for an individual user. What does it mean for you, and how can you up your security game? So I'm excited. It's going to be fun. Now, first up is the CNCF and their approach to security. What I really like about how they approach security is that they've been thoughtful and methodical about it. And the first thing I want to show you is it is an image from their website. And you may or may not have seen it. This image really tells a story of how a project matures through the CNCF ecosystem and really what sorts of users are going to be interacting with a project at a particular maturity level. And why I think this is interesting from a security perspective is that it maps pretty closely and pretty well with your risk tolerance. So basically, as a project matures, it's going to meet security milestones. And so depending on your risk tolerance, if your risk tolerance is higher, if it's not a super critical project, if you're not it's not live to the world, that sort of thing, you're going to be comfortable with the project earlier. But if you're more conservative, if your risk tolerance is lower, then you're going to want to hold off perhaps until something has graduated. And so you can kind of see how a project evolves and how it interacts with the users at different stages. And I just really like this image. Now, what's extra exciting for Helm today, as I talk to you, is that Helm has completed this process. Earlier this year, they graduated, and they are now a graduated project within the CNCF ecosystem. And so congrats to the maintainers. They worked really hard in a lot of different aspects, including security, which is what we're going to talk about. And their hard work paid off, and it was just really nice to see it promoted to a graduated project. So Helm joins other CNCF projects that you know and love in the graduation category, and it was just really nice to see the project be promoted. Now, how does a project get to the graduation stage with respect to security? And that question you can find the answer to in the CNCF GitHub. I'm going to show it to you now. And basically, a project needs to have completed an independent and third-party security audit. They did a bit of a pilot program for a couple of graduated projects in, I believe, 2018 and 2019. And it was a success. And so it has now rolled out to all graduated projects. So I really encourage you to read more about this. I think it's really interesting. They have open sourced their security audits, and you can learn more about the projects and their approach to security in the following slide. There we go. So I'm going to tweet out a link to these slides, and you'll be able to click through and read something I published last year about how Kubernetes open sourced their security audit. It also covers a bit about the pilot program, which included the Core DNS, Envoy, and Prometheus projects, and how it's rolled out to other projects in the ecosystem. Additionally, I have links here for the specific Helm security audits and a further security assurance that they did a few months back. And I think it's just really interesting reading. And great to see from the CNCF that they prioritize security in this way and hold their member projects accountable. And it's just been really great to see. So we are talking primarily about the Helm project, though, today. And Helm, I want to give you kind of an overview of it. And again, this may seem simplistic if you're not brand new, but it's important to say anyway, and that's okay. So we're going to talk about Helm. And the first question you may ask is, what is Helm? Well, Helm is the package manager for Kubernetes. And Helm, it helps you manage your application, and it's maintained by the CNCF through a partnership with Microsoft, Google, Bitnami, and the open source Helm contributors. So if Helm is the package manager of the ecosystem, then what is the packages? Where are the packages? What are they? And the answer to that is Helm Charts. So a Helm chart is a Helm package, and they describe a related set of Kubernetes resources, and they help you define and install and upgrade even really complicated things. Now, Helm charts are things that you can put together your own, or you can certainly use public Helm charts that have been shared with the community. And these public Helm charts, they come in a couple of different varieties. And the ones that I'm going to focus on are called stable Helm charts. And a stable Helm chart are charts that are thought to be mature. So if we think back to that image from earlier, where a CNCF project goes through maturity levels and graduates, we can kind of think of a stable Helm chart as having graduated. It meets some requirements that the community sets, and I wouldn't go to say that it's like a stamp of approval, but it's just an indication that the chart has been tested by the community, that it's trusted generally, and they also have some criteria surrounding security vulnerabilities, and that the images should be generally free of severe ones. All right, so we have these stable Helm charts. And these charts are, they incorporate container images. And the image is the level at which a vulnerability is actually present. So a container image is an executable package of code, and it has everything you need to run an application. So a given chart can contain, or it can make use of a number of images or none, but you'll find that most charts use one or more of these. And the vulnerabilities we're going to talk about are at this level. This is where they're introduced, at this container image level. All right. So we have Helm, the project, which has completed this security audit. And Helm, this package manager, has charts, some of which are community trusted and somewhat approved by the community in these stable chart versions. And these charts contain images, and the images are where vulnerabilities occur. So that's the broad landscape of what we're talking about, and of where problems might be introduced. And let's dig a little bit deeper into the security of these charts. All right. So Helm chart security. And the first thing to say is that this is definitely distinct from Helm security. So the security report, the audit that Helm went through, is really about their process, the project itself, the source code for that project. It didn't really incorporate charts, because charts are things that you and I can make. They're the community, they're not the project itself. So even though we have this security audit for the tool of Helm, we do really need to think about whether there are vectors and problems within these charts. So last year, I had the pleasure of looking into this in more depth, and I wrote a report that we called Uncharted Territories, The Untold Tale of Helm Chart Security. And this was really exciting because, I wrote it, but I worked with some people within Snyk who really, really know the ecosystem. And we were communicating with some maintainers and that sort of thing. And just going back and forth about these things and finding vulnerabilities and being surprised at what's there. And it's just really exciting. I encourage you to read it, and I'll have a link at the end of the presentation for you to do so if you wish. So what are we talking about here? We're going to talk specifically about vulnerabilities within these images. And a vulnerability, for the purpose of this talk, is an exploitable issue present in a container image. And these vulnerabilities can be divided into different classes. You can kind of sort them by type. And each of these types, they correspond roughly to CWEs, which is a common web enumeration. It's a community-developed list of software security problems, basically. So I'm not necessarily going to talk about an individual vulnerability, but the sorts of vulnerabilities that we see most often in these public Helm charts and what implications they have for the community. So just real quick too, if images are interesting because you can kind of think of them as like building blocks, or you're putting together something, and you may think that if I have a vulnerability in a given chart that it's in one place. But really, if the little block that you're using to build this has a problem in it, and then you use that block in several places, the vulnerability is going to crop up multiple times. So this is good because, you're dealing with fewer unique problems. But if you eradicate or remediate a problem from a single location, you're not necessarily taking care of the entire problem. It could be elsewhere in your image, that sort of thing. And so I just wanted to put this up here so it's clear that we're not double counting, if that makes sense. Even though the vulnerabilities may match, they're present in multiple places. So let me show you the tools I used to find these vulnerabilities. First off, I used an open source Helm plugin that was written and maintained by some of my teammates at Snyk. And you can use this too. All you need is a free Snyk account and to follow the instructions that are provided on the README. I'll also have a link for this later in the presentation if you are curious to test your own charts. So I have this plugin, and this plugin, what it basically does is for a given chart, it figures out which images are being used. And those images are they have operating system dependencies, and those are checked against a vulnerability database that Snyk maintains. And then the plugin gives back a bunch of information about the vulnerabilities present, their severity, where they're found, how often they occur in the image or in the chart. And you're able to get a holistic, a wide-ranging view of the security of this chart. So it's really interesting. I encourage you to try it out and to dig into the data that's provided by this plugin. And again, it's open source. All right. So I used the tool we talked about earlier, this Snyk plugin for Helm, and I ran it against every chart that is available in the Helm Charts repo within their stable folder. And had some Python scripts that do this. And it would go through and find all of the stable charts and run this test, right? And load that up into a database, got some data, and took a look into it and see what we could see, basically. Now, the following are some basic Helm chart landscape, just basic things we learned about what are in the public Helm charts. And then I have some more specifics about the types of vulnerabilities and, what we see most often, that kind of thing. So, general thoughts is that most of the stable Helm charts are using an associated container image. So all of these, or they have the potential for vulnerabilities, right? And then the majority of the charts that use a associated container image actually have an image with a high severity vulnerability. And that, I think, was probably one of the more surprising things that I learned during this report. It was higher than I thought it would be. But we also found that there are a total of more than 30,000 operating system package dependencies. So we're really talking about a lot of different dependencies. And in total, more than 40,000 vulnerabilities have been found. Now, these are unique vulnerabilities. So, let me see. So to continue in that vein, the average chart contains 2 images, and all of the charts, or like if you consider, okay, how many images are used throughout these public stable Helm charts, and the answer to that is around 416. For an average chart, you're going to have about 81 operating system package dependencies per image. So if you're using 2 images, you'll have twice that generally. And an image could have anywhere between 0 operating system dependencies to more than 500. And this will correspond to anywhere between no vulnerabilities and nearly 1,000 vulnerabilities per image. And those numbers can seem kind of intimidating, or at least I thought so. But when we really look at it, it gets a little bit cheerier. And one thing I would say that surprised me is that we found that 6 images could account for nearly half of, or so 6 images accounted for nearly half of the vulnerable images that were used within these charts. And that was really interesting to me. It's not to say that these images are the most insecure or the worst or anything like that. Don't take that away from it. What it just means is these images are used frequently, and they do have some vulnerabilities. And because of that, those vulnerabilities crop up more frequently than perhaps more severe vulnerabilities found in more obscure images. So it's not necessarily to say that like these are bad offenders or anything like that. We just want to understand where the share of the vulnerabilities are found and what we can do about it. So to continue, I also was able to break down the vulnerabilities by type, which was really exciting. And you'll see here, this is by type and by severity. So the thing is, you will find some pretty severe problems. And they're really things that we're going to want to look at and consider how we might remediate or how we might further protect ourselves. So the highest in this chart would be a 9.8 for a particular access restriction bypass vulnerability and some credentials management stuff. All right. So I also wanted to point out this chart, which is, it'll show us the share each kind of vulnerability has within the landscape. And I have picked the top 3 to discuss just a little bit further, and we'll be able to basically know what sorts of things you could do to protect yourself. So we're going to do that now. So the first I want to talk about is an out of bounds vulnerability. Now, these are really interesting. They come in two flavors. It could either be out of bounds read or out of bounds write. And in either case, it involves accessing data outside of the intended buffer. And in this case, you can solve a lot of these issues and protect yourself with careful handling of input data. So it may include a whitelist system. You may check buffer lengths. So you can be sure you're not getting data you're not expecting, that sort of thing. So even if these are present, there are things that you can do to help protect your project against this. So of the two types, out of bound write is more of a problem because in addition to accessing data, you may find someone who is able to execute some code. And the possibility of this malicious code execution, it makes this one worse than the out of bounds read. This vulnerability can be managed by checking your buffer size to make sure you don't have anything unexpected. You can also make sure that the destination buffer size is equal to the source and truncate anything that doesn't make sense. And if you do these sorts of things, it'll help you be more secure, and you'll have to worry less about this kind of vulnerability. All right, so after out of bounds, we're going to talk about access restriction bypass. Now, access restriction bypass vulnerabilities are the second most common type that I found in the Helm charts. And an access restriction bypass can occur a number of different ways. You can think about it as like basically someone is able to get past a check of their identity in some way. So in real life, this may be like being at a club, and instead of going through the front door and getting verified by the bouncer, you found a side door propped open and got in the building that way. So that's a real life kind of version of that. But you may also be able to do things that the creator may not wanted to have given you that permission. So maybe someone in the club is able to charge a drink to a tab that they shouldn't have access to, that kind of thing, for the real life example. So finally, the accountability might be bypassed. So what this means is that generally you're going to do some logging of user behavior. And if you're intending to do this, but you don't, someone could be doing malicious things and it's not getting recorded and it's flying under your radar. So when you approach these sorts of problems, do it on two fronts: specification and enforcement. Specification involves being thoughtful and deliberate about how your permissions are assigned. And enforcement occurs when the program fails to adhere to the guidelines that an admin sets. So if there's a known enforcement problem, it would just serve you well to write some tests and run them and ensure that your highly sensitive data and your highly sensitive functionality are protected. A null pointer dereference occurs when a pointer with a value null is treated as though it pointed to something valid. And basically, you can get a stack trace and people can potentially exploit it, but maybe not. And so it's just, you can do a lot with like error handling and that sort of thing. So what this means for you is remediation. fix the images, choose images well if you can. Use your tools with open eyes and consider all of your vectors. So what I mean by that is you may feel good about using Helm, and you should, because they have invested in security, right? But you want to use the tool with open eyes, knowing that there could be problems and knowing that problems could come from different vectors like the charts. Also, I would say that you should test your charts, and you can do so with the plugin that I mentioned earlier. Finally, I would say you can up your security game by using Helm best practices, which I will link later in the presentation. Migrate to Helm 3 if you haven't already. Lose what you don't use in case you want to minimize the surface area that is vulnerable to attack. If you're not using an image or a chart, or if you don't really need it, don't use it. And finally, I would say to consider your configuration. This is a big deal, and all graduated projects should use secure by default configurations, but you want to be thoughtful about this, and it'd be good to run this by someone if you're unsure. So I do want to say thank you. Thank you for having me. It's been a pleasure. Thank you to the Helm maintainers. You've done excellent work, and I'm so happy for you that your project graduated. Thank you to the folks listed here who are on my team at Snyk. You were very helpful and great. And thank you to Growth Labs, who is responsible for some of the images shown in this talk. Here's the link to the resources, and I hope you take a second to check it out. And finally, I just wanted to give you my contact info. I would love to hear from you. And we'll go to questions.